Good morning. Good morning. Thank you for joining me. So, just to introduce myself, my name's Jimmy Lamb and I'm the sales manager for Dryden Aqua, manufacturers of AFM filter media. Okay, see you, Robbie. He's heard it all before anyway. Good morning, good morning. Welcome, ladies.
You missed the train.
Oh dear, okay. The topic I'm going to talk about today is the same presentation I gave yesterday in the SPA arena. So I see there's one or two familiar faces that sat in yesterday's presentation, but a bit of repetition doesn't hurt. So as I said, my name's Jimmy Lamb, sales manager for Dryden Aqua. I've been with Dryden now for nearly 3 years. I've been in the swimming pool industry for over 20 years. We try and make these presentations as generic as possible, which is quite a challenge when you've got quite unique products. So there is a commercial side to this presentation, which I apologise for. But there's a lot more information I have here if it's something that's of interest with you following the presentation. But I want to present how our technology can help commercial pool operators prevent cryptosporidia outbreaks in pools and also at the same time reduce energy costs. So I'm going to start off by looking at what is cryptosporidium and the illness that it causes, the cryptosporidiosis. Have a little look at some outbreak cases in the UK. I found some analysis online on this subject. I'm going to deep into the biology, so biological activity that occurs in swimming pools and places where crypto can hide within a system. The Dryden solution, this is the commercial part of the presentation, and a little bit about filtration performance as well, comparing different medias. And then the energy saving part of it is really looking at medium pressure UV versus development in similar technologies, utilizing UV technology to achieve the same results without the energy consumption. So what is cryptosporidia? Well, this is some research I did and found this from PUTAG, the Pool Water Treatment Advisory Group. And they say that cryptosporidia is a protozoan parasite that multiplies in the gut of humans and other animals. Okay, so it's not just coming from us. In the life cycle stage that is shed in feces, lovely subject to talk about mid-morning, is called an oocyst. People become infected when they swallow the oocysts, and one single cell is enough to make someone ill with cryptosporidiosis. And this is a figure that I want you to remember. Okay, so the typical size of a cryptosporidiosis is around about 5 micron, typically 3 to 6 micron. Cryptosporidia is it's a very hard-shelled parasite, which makes it very difficult to control just with disinfectants, such as chlorine. Even very high levels of chlorine find it difficult to actually penetrate and kill this parasite. Cryptosporidiosis is the illness caused by the infection of cryptosporidia, and anyone can get cryptosporidiosis, but it's especially common in young children. And the main symptoms are watery diarrhea, abdominal pain, nausea, and or vomiting, and a low-grade fever. People might swallow the oocysts when they have close contact with an infected person or animal and their feces. Or through eating contaminated food or swallowing contaminated water. Most people become ill 5 to 7 days after ingesting the oocysts. So in some instances where there's been an outbreak, it might be quite difficult to actually trace where that outbreak has come from. Symptoms typically last up to 2 weeks, but sometimes longer, and may come and go before full recovery. And people with a weakened immune system could be quite a serious condition, and possibly life-threatening for these individuals. So it's a serious potential problem that we have to deal with. So I turned to Dr. Google, as we do, to try and do a bit more research, and I came across this study. It's a few years old now, but this was a paper that was put together by Public Health Wales in conjunction with Public Health England, and it's guidance for the investigation of crypto linked to swimming pools. Okay, so I've just taken a few snippets from this, but you can find this readily available on the internet. So we said at the beginning there that crypto can come from humans or from animals, and the type of crypto that comes from humans is the crypto parvam, and the one from animals is the crypto parvam is coming from animals, and the crypto hominis is coming from humans. And you can see here that the large contributing factor to crypto outbreaks in recreational waters is the type that's coming from humans. So this is people having fecal release into the pool. And the majority of those 52 outbreaks in this study are attributed to the main swimming pool itself, which I was quite surprised at, actually. I thought, baby swim schools, swimming pools might be a little bit of a higher factor, given that babies are using these type of pools. But no, the majority was the typical swimming pool that we're using. It doesn't seem over the period of this study that we are getting any better at controlling these outbreaks, or maybe it's just we're more aware of it and we're doing more testing to find out where these outbreaks are coming from. So there's certainly room for improvement. And another interesting feature of this analysis was most of the outbreaks occur during the holiday period, August, September time. So of course schools are out there using the public baths, or they're away on holiday using swimming pools on their holiday sites. So. The typical problems that have contributed to the outbreaks of cryptosporidiosis are listed in this publication. So they talk about inadequate pool design and construction, including water features. So it's not just attributed to the swimming pool itself. I'm not quite sure what the second one is pertaining to. Sewage cross connection almost suggests that when you're flushing the toilet in the public facility, it's discharging into the pool. So I'm not quite sure what they mean by that one. Fecal release or contamination from bathers. This has clearly got to be the largest contributing factor, I would have thought. Excessively high bather loads, and we know that commercial operators are under pressure to improve revenue streams, so there's a temptation there to load the pool with more bathers, perhaps over the subscribed number that the system's been designed to deal with. Inappropriate handling and disposal of stools, and inappropriate response to fecal accidents. So this is your emergency action plans, putting these into action when we know that there's been a fecal release in the pool. I think probably solid stools are a bit more easy to detect if we've got a floater in the pool, but perhaps where there's been a loose, shall we say, diarrhea discharge, then it might not be so readily to detect. Inadequate pool circulation, coagulation and filtration. So this is really our field of expertise, and this is what I'm going to drill down on, along with filter backwashing problems. Inappropriate backwashing procedures as well, and then finally ozone or UV treatment not working properly. So it's typically recommended by PUTAG that commercial pool operators utilize medium pressure UV technology, and this acts as a belt and braces of protection against crypto, but it also helps to reduce combined chlorine as well. So we'll go into a bit more depth on that towards the end of this presentation. Section 3 of this document, come on in guys, morning. Section 3 of this document covers swimming pool water treatment and quality. It talks about the basic principles of swimming pool water treatment, disinfection and efficacy against cryptosporidium, bathers and bather numbers, swimming pool design and circulation, and finally filtration. And in the summary, what's really interesting is that the removal of these oosysts from pool water really relies on good circulation, so a good hydraulic of the pool, with optimal filtration, coagulation and flocculation. So this is to create a barrier to actually capture these oocysts from the system. Now, Dryden Aqua was founded on the basis of biology. The company was founded by marine biologists. So they've approached pool water treatment from a biological perspective. So let's have a little look at biological activity in a pool with a typical sand filtration system. I know some of you have got a smile on your face. You've seen this slide a few times over the years. How do bacteria survive in a pool? Because it's not a sterile environment. You know, there's always going to be a level of bacteria present, and this is why it's a must that commercial pool operators have a microbiological test done on a monthly basis. But you're always going to come back with a positive reading of a level of bacteria in that test, and it's the proof that the system you've got in place is adequate to deal with the contamination that's entering that pool. So we're allowed to work within certain parameters of bacteria count in a pool. Now, some of these bacteria are quite fragile and they will be killed quite quickly by the disinfection in the water, typically chlorine. Some have got a bit more of a resilience, and what they're trying to do is they want to reach a surface. So once they've found a surface to stick to, they will then secrete an alginate around themselves. So they're now protected from the oxidizer in the water. And this is the early formation of what we call biofilm. Okay, so what are the available surfaces in a swimming pool? Well, there's the pool tank itself. I mean, that represents a huge surface area, the floor, the walls. Come on in, guys. And right enough, if we don't maintain the surface of the pool on a regular basis by brushing or even using a robot to sweep the floor and the walls, in time we'll start to get a slimy film growing on the surface of the pool. Once that slime is established, the biofilm is established, even very high levels of chlorine simply cannot penetrate this biofilm. It will oxidize a lot of it, and in fact a lot of the chlorine will get consumed as it's trying to oxidize this slime and the bacteria contained within. And you see on typically domestic bottles of bleach, you know, kills 99.9% of germs, but there's still that little bit of germs, that's resilient to the disinfection in the system. And you can get what I call the antibiotic effect. You know, if you've been unlucky enough to get some kind of infection and you see the doctor and he will prescribe a course of antibiotics, it might be a 5-day or a 7-day course, and he tells you, please complete the course. But the infection's gone within 2 or 3 days, so the temptation is to stop taking the antibiotics. But there's still a little bit of that infection remaining in the system, and it will grow an immunity to the antibiotics. So that's why it's really important to finish the course of antibiotics. So we can get the same thing happening in bacteria and biofilm, where they grow an immunity to the oxidizers in the water, and that you would get superbugs growing in the system. Biofilm is also an area where Cryptosporidia can hide and lurk within a biofilm. So it's really quite important to make sure that we're maintaining our system and trying to keep it as free as biofilm as possible. So I mentioned there that the pool tank represents a large surface area, but when you start to think about the entire system, the pipe work, that there's available surface within the pipe work, which is a little bit more difficult to reach. In these instances, chlorine dioxide is always a good treatment, because chlorine dioxide is a soluble gas, and this will penetrate and remove the biofilm from the surfaces, whereas chlorine's attacking it from the outside in. But the chlorine dioxide gas will actually penetrate that biofilm. But still, the pipework is still a very small surface area in the entire system. If we look at the filter, and specifically the filter media, and you consider the amount of sand that's contained within a filter, every sand grain has a surface area, and when you multiply that up, that will represent well over 90% of the total surface area that the pool water is in contact with. And this is where we're hopefully trapping dirt and particles. This is the purpose of the filter, yeah? It's the dustbin for the pool. And it's a nice warm environment, so it's the perfect environment for bacteria to grow and to create these biofilms. And this is one of the reasons why we need to change sand on a regular basis, typically every 5 to 10 years, is the advice from PewTag. Because typically what's happening is the bacteria is sticking to a grain of sand, it secretes the alginate to protect itself from the harsh environment of the chemicals. That then sticks the neighbouring grain of sand together, and so on and so forth. So we start to get these anoxic zones growing within a filter, or mud balling, as it's sometimes referred to. The water under pressure is trying to percolate down through the media bed, and then that will start to push these anoxic zones to the side, and the media bed opens up. So the particles that we're trying to trap simply now pass through the media bed, and then occasionally we can get a rupture of these anoxic zones and a release of bacteria back into the pool, and it destroys the chlorine residual very, very quickly. So we get the bacterial floc discharged into the pool, the turbidity increases, the chlorine consumption increases because it's being consumed by a contaminated filter, and the filtration is no longer stable. So this is when we need to consider doing a media change. That's a good picture of wormhole channeling. This is in a domestic filter, which is under a much higher velocity compared to commercial pools. And if you ever have the pleasure to go out and do a media change, you might relate to that picture. I admire the use of PPE gear with this one. But it can be quite an unpleasant job, particularly when you get right down to the bottom collector system of the filter around the laterals, the nozzle plates. This is where we typically have dead zones, a lack of flow of water. And yeah, it can be pretty grim down there. So coming on to the more commercial side of my presentation now, this is the Dryden solution to help protect against cryptosporidia, and that's by employing our technology in what we refer to as the DAISY system. So that stands for the Dryden Aqua Integrated System. So let's go into a little bit more depth on this. So by simply replacing the sand for our activated filter media, which goes through a process, it's an engineered product that goes through a process, and the resulting factor is that it's 100% bioresistant. This means bacteria simply cannot reach and touch the surface of the glass whilst the water's passing through the filter. So you start to understand now, if we are replacing that 90% of surface area with a surface that doesn't coagulate by biofouling, doesn't grow the bacteria within the system, you can start to appreciate why the chlorine consumption is reduced. We also get a much more efficient backwash with our media compared to sand as well, because it's not as dense, and the shape and the size of the granule is engineered in a way that gives it good fluidization in a backwash. So we're typically reducing water consumption by about 50% in commercial applications. We're reducing the backwash period by about 50%. So how do we make it? And we always welcome visitors up to our plants in Scotland. We've got a Pool Professionals Day on the 7th of May. If you want to find out more about that, come and see me after the presentation, and I can add you to the invitation list for that. We've got two plants, one in Scotland in Edinburgh and the other one's in Switzerland. The only difference between the two is how we receive the raw materials and when we wash it. So up in Scotland, we receive well over 50% of clear glass, clear bottled glass. We consider this a waste product. It doesn't make for very good filtration material. So we need to sort that. We need to take that out and then repurpose that elsewhere. So that goes back to making whiskey bottles or medicine bottles, for example. And in fact, we've just invested another £2 million in that process to make it more efficient to remove that clear glass. Whereas in Switzerland, it's the recycling culture is a little bit different there. So they're still taking the bottles to the bottle bank, putting the green bottles in the green, the brown in the brown, and the clear in the clear. So we actually receive over 90% of our target colour glass, which is green and brown, and I'll explain why shortly. So we are taking these bottles from the bottle bank. We simply put them into a large hopper at the beginning of the process, and now we have to remove the labels, for example, that are stuck to the bottles, the enclosures, whether they're plastic enclosures or ferrous or non-ferrous materials in here. So that's through a process of magnets, eddy currents, suckers, and blowers. All the waste products, as I say, we repurpose, whether it's ceramics, coloured glass, clear glass, even the sludge that's used in or that's produced in the washing process goes to producing biogas. The whole plant in Switzerland, I hasten to add, is actually powered 100% by solar power. Now, we don't have that luxury in Scotland, understandably. So, you know, we've maintained that ecological ethic from the founders of the business, marine biologists, and try to be as green as possible. We harvest the rainwater. We don't have a problem with that in Edinburgh. In Switzerland, we usually have enough water to last for about 3 months without rain. This is used in the washing process, and then that's recycled as well and filtered with our own technology. And as I say, yeah, the sludge that's produced, that goes off to producing biogas. Once we've got the raw materials washed, it then gets sterilised through a heating process, and we get the maximum loose organic contamination down to less than 10 grams per tonne. Okay, that's really important as well, and you'll see why when we come on to a certification on the product later on. Now we need to pick out the target colour that we want, green and brown. So AFM is 98% just green and brown glass. So why that target colour? It's the metal oxides that give the glass that colour. So in the case of green glass, this is chromium oxide, and in the brown glass, this is ferric oxide. This already has a natural bioresistance. When you buy fine wines, they usually come in a green or a brown bottle. Your cheap Lambrinis are in a clear glass, yeah. So it gives the wine longevity. So we're just harnessing this metal oxide in there and put the material through what we affectionately call the beast. And this machine is doing the shaping and the sizing of the various grades that we produce. So we typically produce 4 grades. Only 3 of them are used in swimming pool application, depending on the size of the filter and whether it's a nozzle plate or a lateral system. This thing shakes the whole building. You know when the plant is running because there's a bit of a vibration throughout the whole building. And then the final stage is to give the glass a certain charge. This is the activation process. Okay, and this is something you can witness. This isn't behind curtains. This is something you can go and witness. And this is where we manipulate the surface of the glass. So we produce 2 types of AFM. The original product is called AFM Standard. This carries a negative charge. So negatives attract positives. This was very good at filtering, especially in water treatment processes for removing heavy metals, for example. So iron, manganese, copper. The latest version that we introduced in October 2020 has a neutral charge to it, and it's actually a hydrophobic material. So it's frightened of water, which might make it not much use in swimming pools. But it actually improves the performance better than the original standard. Why hydrophobic material? Hydrophobic materials attract other hydrophobic materials. So the developer of this wanted to produce a media that would filter out microplastics, for example, which are hydrophobic. So it's excellent at removing microplastics, which amplify forever chemicals. You've been hearing about this lately in the news. So there's a desire from our founder to try and clean up our oceans and prevent these microplastics from entering the oceans right from source. So that's a project we're still working hard at with the water authorities to get them to adopt our technology. The process of the activation is a closely guarded secret. I don't know the chemicals that are used to manipulate the surface of the glass. There's only a handful of people in the company that do, and they're not allowed to share the same car or get on an airplane. It's like the KFC secret recipe or Coca-Cola. But you get to witness this, as I say, if you choose to come and join us on the 7th of May. And then we have a very strict quality control process as well. So the computer at the loading bay will randomly select a bag from every batch, send it through to quality control, and they'll do some tests to make sure that we're still producing to our standards. And everything's traceable, right from the raw materials to the finished product. Every bag is barcoded, so we can trace it right back. In terms of its filtration performance, it's really important to get the product independently verified. So we originally approached the German DIN committee, and they pointed us to this laboratory in France, the IFTS, the Institut de Filtration Techniques Separatives, or something like that in my best French. This looks like quite a complicated chart, but if you go down to the bottom here, this tells us that AFM removes 94.6, let's call it 95%, of particles down to 1 micron in size. That's at a filtration velocity of 20 meters an hour, so the type of velocities that we would expect in commercial applications. This is probably a better chart to understand. So across the bottom there, we have the size in particles, and on the left-hand axis is the percentage of removal. And I say again at 20 meters an hour. So if we draw a line at that 95% of particle removal, you can see there that AFM NG is removing 95% particles down to 1 micron. The next best performing media that was tested in this round of tests was sand, filtering at 20 micron. Okay, so now I'm coming back to remind you, what was the average size of a cryptosporidiosis? About 5 micron. So you can see when we're filtering with sand, even at these slow velocities, crypto can just simply pass through a sand media bed. Whereas AFM, we are creating that barrier. In a single pass, we're going to capture that, that pathogen. The other graphs that you see on there are other types of media that were tested from different glass suppliers, but not any of them could get close to even sand, let alone our technology. Okay, any questions on that at all? I mentioned the shape and size earlier. And this is really important if you want a product to comply with this new standard that was published at the tail end of 2024. So this is the EN 17978 that's been adapted by British standards, so BS EN 17978 2024, and it's a quality standard. This isn't a performance standard, this is just a quality standard. And it's for products used in treatment of water intended for human consumption and swimming pool water, glass beads and glass granulate. So I'll say this was published in December 2024, and these are the parameters that your product needs to adhere to qualify for this accreditation. So the first one is the total organic contamination, up to 300 grams per tonne, while we're under 10 grams per tonne. So that's a big tick for us. The next one is the magnetic contamination. You're allowed up to 50 grams. We have barely any metallic contamination within AFM. But I think this is the really interesting one, the over and under size of each grade that you're producing. So if our grade 1, we're stating as at 0.4 to 0.8 millimeters, we've got a tolerance allowance of 5% on that size. Now you need quite sophisticated equipment to actually measure this, which we have. You know, we made big investment. Filtration is our business. And for the support grades, it's you've got a bit more of a wider tolerance of up to 10%. I often get asked the question, how long does AFM last? Mentioned earlier, because the biocoagulation that occurs with sand, it needs to be changed every 5 to 10 years. We've got AFM in a commercial pool up there at the Leisure Drome, just outside Bishop's Briggs, and that will be 22 years this May that it's been in situ. Now they've got a very well designed plant there. You can see the picture of the plant there, very generously dimensioned in terms of the pipe work, the filtration. We get really good hydraulics in backwashing, because backwashing is really important to make sure that you fluidize the bed by, expand and fluidize the bed by at least 15%, preferably 20%. And in the studies that we've done, AFM grade 1 will fluidize to 20% at only 30 meters an hour. Now, why is 30 meters an hour a significant figure? And that's because PUTAG recommend that backwashing is carried out at a minimum of 30 meters an hour. With sand, you'll probably get about a 6% bed expansion at that velocity. You'll actually need 50 to 60 meters an hour to fluidize sand to 15 to 20%, depending on the shape and size of the grain. It varies depending on where that sand has come from. 30 meters an hour doesn't mean to say that that's a high enough velocity to actually remove all the trapped particles. This is just about bed expansion. Okay, it might be that we've got quite large and heavy particles that need a bit more energy and a bit more velocity to actually lift them up and out of the filter vessel. So we normally recommend a minimum of 40 meters an hour, even higher if the system is designed to accept those higher flow rates. But by doing so, you can actually save even more water. It didn't make sense to me at first when our CTO was presenting his studies, his R&D to us on this subject, that if we double the velocity to 60 meters an hour, we actually reduce the period of backwashing time significantly, so we use a lot less water, significantly much less water. But the whole system needs to be designed to accept those flows. So the message here is AFM will work great if you're restricted to just 30 meters an hour. But what I would recommend is that you do not use a coagulant or a flocculant, because it's a sticky substance, and we'll come on to it in a minute, and it will bind within the media, and it will need a bit more velocity to actually shake that up and release it from the media to eject it from the filter vessel. But I visited the Leisuredrome. It's going back a couple of years now. I've updated the slide last year to 21 years. I need to update it again soon to 22 years. And I measured the turbidity of the pool water there and compared it with the incoming water. And there wasn't a lot of difference. The pool was at 0.27 NTU. The maximum acceptable level, according to our standards, is the same as drinking water at 0.5. And the incoming water was 0.24. That's not unusual for me to find these kind of results with our technology in situ. So we believe we've got the most sustainable filter media for your pool. We do like a good movie at Triton Aqua. We've got 3 YouTube sites where you can go and find out more information about our technology. I'm not going to play this one because it's about 3.5 minutes long, but it's explaining everything pretty much that I've just said. So that's the heart of the system, is just simply replacing the sand for AFM. To make it a daisy, now we bring in coagulation and flocculation. You can use standard PAC, polyaluminium chloride. We have developed our own that we call APF, all polyfloc, and this is the step 2. Best coagulation, flocculation with APF. And this isn't an exact science. This is on a factor, but we are putting this back to IFTS to try and get some accreditation for this figure. But when you bring in a coagulant flocculant, you typically improve the filtration performance by a factor of 10. So if we're already removing 95% particle down to 1 micron, bring in coagulation flocculation with APF, we get the filtration performance down to 0.1 micron. So we are now into the field of ultrafiltration. It's PAC based, but we have other ingredients contained within APF, such as lanthanum. Lanthanum's an excellent coagulant for removing nutrients such as phosphate. And phosphate is undesirable in pools because it's a food source for bacteria and algae. And unfortunately, a lot of water authorities are introducing phosphate into the mains because the surfaces that phosphate come into contact with, it leaves a residual, and that can help prevent corrosion, which is great for old cast iron lead or lead pipe work. If you've ever done a phosphate test and you've had a positive reading, it's really important to wash the test equipment with a mild acid or deionized water so that you remove that residual of phosphate in the test equipment. Otherwise, you could then go on to the next test and get a false positive. So AFM with the right hydraulics, introduction of APF, we get the particle removal down to 1 micron. Everything that can be filtered out that then does not need to be oxidized by harsh chemicals in the system. And it creates that optimal barrier against cryptosporidia, should it exist in the system. Even Giardia, we didn't even talk about Giardia. That can give some pretty unpleasant side effects if you were to contract Giardia. This it's a little bit more prone to being killed by chlorine compared to crypto. So the benefits of the complete DAISY system, as I say, is the filtration performance. We create that barrier to protect ourselves against cryptosporidia. We're not giving a haven for crypto to hide within a biofilm on that 90% surface area. Because we're not growing bacteria in the system, we can reduce the oxidation demand by up to 80%. I think the first thing that most people notice when they move onto AFM is just the clarity of the water. It's just outstanding. So it's clear, safe, and without the pathogenic bacteria. Healthier air, trichloramines and THMs reduced by up to 50%, and I'll come on to that in the next slide. And overall operating costs, water savings, chemical savings, which every commercial operator is looking for in the current climate. So let's go back to a bit about the biology and what's happening when we are in a swimming pool as bathers. Whether we like it or not, when we're submersed in nice warm water, we are secreting substances from various orifices in the form of sweat or urine. And that's made up of these molecules. So 80% of the substance is urea. And urea is a perfect nutrient, again, for bacteria to absorb and metabolize and convert to ammonia. And then the ammonia then reacts with the chlorine and we get the formation of harmful trichloramines. In an AFM system, because we haven't got the bacteria consuming the urea and creating the ammonia, the urea remains urea, but it still reacts with the free chlorine. And it forms an organochloramine, whereas the ammonia forms an inorganochloramine. So there'll still be a bit of areas within the system for bacteria to survive and consume the urea and create the ammonia. So we do get a little bit of inorganics, but a lot less compared to that of a sand system. But when we add our DPD number 3 to our DPD number 1 test to show our total chlorine, to allow us to calculate our combined chlorine, it doesn't differentiate between the two. They all show up in your DPD number 3 test. So what we don't guarantee is a reduction in your total combined chlorine. What we're not producing is the nasty ones, the volatile ones. You know, the ones that went through agitation of the water, it gases off, and you get that horrible chlorinous smell, irritates the eyes, nose, and throat. This is trichloramine production in a system. So in some countries where combined chlorine levels are monitored more rigidly than they are here in the UK, we need to have a solution to that. Now, typically in the UK, UV medium pressure systems are recommended for 2 reasons. First of all, because it will deactivate cryptosporidia. It's very effective at deactivating cryptosporidia. It's also a very good solution to reducing your combined chlorine. I'll give you an example of some of the acceptable levels in our European partners. So Switzerland, Italy, and Germany, for example, they're allowed a maximum of 0.2 milligrams per litre of combined chlorine. You compare that to our standards, not regulations, standards in the UK, we have a recommendation of no more than half that of your free chlorine with a maximum of 1 milligrams per litre. So worlds apart from our European partners. So the authorities can actually shut the pools down in these European countries if they exceed that 0.2. So that can be quite a challenge for some of the pool operators over there. Another way of reducing a combined chlorine is to simply lay a thin layer of activated carbon across the top of the media bed. Not too deep, because activated carbon can become a harbour for bacteria as well. About 5 centimetres would be enough. You'll still lose a little bit of chlorine as the water passes through that layer of activated carbon, but it will remove the inorganics and the organics combined chlorines as well. It will break down over time, so it does need to be replenished probably on an annual basis, and it's really important that you have a rinse cycle as well when you use the activated carbon solution. So it's probably a cheaper, less sophisticated way of dealing with that problem, but can be very effective. The other option is I want to introduce you to advanced oxidation technology, Advanox. Okay, but first of all, let's have a look at the wavelength of a medium pressure system. You can see it's over a very long wavelength. So this needs quite a lot of energy to produce this wavelength, compared to a low pressure system, which is the black line, which is over a much shorter wavelength of UV light. With the medium pressure, you will lose some free chlorine, as you can see the green line as it passes over the wavelength of the medium pressure. So you do lose a bit of free chlorine that's passing through the medium pressure UV chamber as well. But as I said, it is very effective at taking out the combined chlorine. You can see the black line there, this is our monochloramines, the red line is the dichloramines, and the green one, the volatile one, are the trichloramines. So it's very effective at reducing those combined chlorine. So it makes sense to employ this technology. And we don't have anything against medium pressure UV. In fact, we have other products within our assortment that can assist when you've got medium pressure UV in place. But it does require a huge amount of energy to run these systems. And they need maintenance. They have sophisticated cleaning systems on the quartz tubes because they are susceptible to scale and slime, so they need to be wiped on a regular basis as well. So they do need good regular maintenance. What's happening through the process of oxidation in a medium pressure UV when we've got organics in the system? So an organic molecule is a long chain molecule made up of carbons and hydrogens. With medium pressure UV, sorry, I keep knocking the mic, we're basically chopping up that molecule into smaller molecules in the form of a methane. So this is the smallest molecule. So we've got 1 carbon now and 4 hydrogens. We then get an atom exchange with the chlorine in the water. And we form what's called a chloromethane, so an exchange for a chlorine for a hydrogen. So we've got 1 carbon, 3 hydrogens, and 1 chlorine now, the chloromethane. We then get another atom exchange to form a dichloromethane. Guess what's coming next? Trichloromethane. And this is the volatile one again. And again, through agitation of the water, if you've got any water features, flumes, slides, this can be released into the aerosol without you even knowing it, because it's an odorless gas. You wouldn't even know it's there. It's very difficult to monitor and detect, but it's there. And this is one of the things that the founders of our business recognized was happening with marine mammals kept in captivity who are basically living in chlorinated systems. They have a much shorter life expectancy compared to those living in the wild, dolphins, for example, because they are 24 hours a day breathing in these toxins, these chlorine byproducts. So we want to prevent this from happening. So we have a solution to this. It's called advanced oxidation. We call it Advanox, and this is employing low pressure UV technology, but in conjunction with another chemical. So we use hydrogen peroxide introduced to the Advanox system on a bypass, and with a high dose of UV radiation, typically 5,000 joules per meter squared, this is acting as a catalyst. It's breaking the hydrogen peroxide molecule, it's splitting it to create hydroxyl radicals, free radicals. These have got the highest oxidation potential of any substance, but they're very unstable and they're very short-lived. But any organic matter that they come into contact with, it's a complete oxidation process with no byproduct to that. So there you see the bit like a Star Wars picture, isn't it? You've got the contaminant in yellow. This is our organic molecule. The hydrogen peroxide, the high intensity UV light, disrupting that molecule, creating the free radicals that then oxidize 100% the contaminants. It will even remove substances that you didn't even know were there. And I'm not even going to try and pronounce some of these substances. These exist even in our drinking water. So why is Advanox better than medium pressure UV? Both deactivate cryptosporidia. With our DAISY system, we're creating a barrier. Medium pressure, increasing potentially the THMs through agitation of the water, consumes chlorine. Advanox will also consume some of the free chlorine because not all of that hydrogen peroxide is converted or disrupted. So it will react with the free chlorine and you will lose a little bit of free chlorine, just as you would with a medium pressure UV. But it's really the expense, the energy hungry UV, where we really make some gains. So let's do a cost analysis. So I went to 2 installers of medium pressure UV systems to get this information, based on a pool with a volume of 500 cubic meters. The cost, the capex for each of these systems, the medium pressure was just under £17,500 compared to the Advanox just over £11,000. So we've got a significant saving straight off the bat. We put an installation cost the same. They're 2 completely different types of installation, but just to give it a level playing field, we've gone with the same figure for both systems. I think the Advanox would probably be slightly less because of the size of the pipe required for it. The lamps are very different in terms of their energy consumption. So we need a 3 kilowatt lamp for the medium pressure compared to 2 300 watts of the Advanox system on this one. Cost per kilowatt hour, commercial cost per kilowatt hour, 26p. hopefully about right. If the lamps were running 24 hours a day, that's how much the cost would be to run each systems for a day. So you can see there's a significant difference here. And if we multiply that up per year, again, you can see where we're going with this. Life expectancy of the medium pressure is about 9,000 hours before it needs to be replaced, compared to 24,000 hours of the Avanox, because you get a spare set of lamps automatically when you buy a system. Number of lamps per year, again, significantly different. And then the maintenance costs. So this is the guy coming out and servicing the system, maintaining the wiper system, cleaning the quartz tube, because we don't need wiper systems on an Avanox system because it's not generating that heat. We put a slightly less figure in for the annual maintenance of that. Of course, we've got the chemical that's used through Avanox, hydrogen peroxide, so that comes at a cost. And this would be the dose rate typically for that size of pool. Hydrogen peroxide is available in 2 different strengths depending on whether you're a domestic user or commercial user. So that would be the volume required for each of the 2 different strengths and the consumption per year for the 2 different strengths. And then I spoke to the biggest supplier of chemicals in the commercial pool market to ask what they would typically charge for the stronger of the 2 strengths, because I think that's what the commercial operator would use. So over a year, it's pretty insignificant in the grand scheme of things. It's just shy of £600 per year for the hydrogen peroxide on that size of pool. Now, if the system was operating 365 days a year, this is the difference in terms of the capex including installation. And then this would be the annual running cost between the 2. So you see significantly different. In fact, capex and opex, 32,000 compared to 20,000. So in the first year, we're actually saving just over £11,500, which is a significant amount of money for any commercial pool operator. And then annually, they're going to save £5,500 just on the running cost. Okay, so we believe we've got the best solution in DAISY with Avanox to protect yourself against cryptosporidia, reduce your chemical consumption, water consumption, the energy efficiency of it, creating a healthier bathing environment. Much better and healthier than a medium pressure UV system. As I say, we're not against medium pressure UV. We can bring in our product called ACO before a medium pressure UV chamber to create more of these hydroxyl radicals, so utilizing the power of that UV to create hydroxyl radicals that way. We think it's as good as a pool on ozone, which was always said to be, the best system for good water quality. But ozone systems are very expensive and to maintain as well. It can be quite temperamental sometimes. So. We'll do it for time. Okay. So as I said at the beginning, we have a number of YouTube sites. My favorite is our Dryden Pool Academy site. We've got 16 different sessions on there, anything from 30 minutes to an hour, covering different subjects of pool water treatment. And in fact, the session I've just given you today is session 16 on here. So you can go back and visit that at any time at your leisure. Any questions at all? Oh, hang on, it's got a microphone coming.
In that you mentioned you didn't like the flocking it because it makes things sticky or somewhere. I can't.
That's if we've
what was
got
that about?
Yeah, if we've got restrictions in flow for backwashing, and you've used a polymer coagulant, a polyaluminium chloride, for example, the coagulated matter will be bound into the media. So you need a good velocity to really break that up and eject it from the filter. So if we've got a restriction on backwash flow, let's say 30 meters an hour, I would say switch the flock off.
What?
So,
Permanently?
I mean that in the politest possible way.
Do you mean permanently, or do you mean...
Yeah. Unless you can increase the velocity.
Oh right, okay.
Yeah.
But with APF, it's the same problem.
Yes. Yeah.
So it is still the same product.
Because we're filtering down to a much finer micron, the media will choke up quicker. So you do need that velocity to fluidize and expand the bed to release the trapped debris. As I said, even 30 metres an hour, I said, without flocculant, still might not be enough to eject the trapped debris, because that trapped debris might be quite heavy and dense.
Yeah, you can see it. You can see
And it needs lifting up and out of the filter vessel. If it remains in the filter, it will then become a harbour itself for bacteria, and you can get the same problems occurring with the trichloramine production.
But you lose quite a lot of your system if you do that, though, don't you? Really? If you don't
Sorry?
have- your system is designed to have use flocculant, isn't
Absolutely,
it?
yeah.
So
yeah.
you lose a lot of a lot of the power of what you're producing if you do take the flocculant out.
Yeah, so this is
a
why
compromise.
this is why we always like to have good hydraulics in
Yeah,
the system,
yeah,
but
yeah.
you'll still get excellent results if you use AFM alone compared to the sand that you were using before, because you're going from 20 micron, if you saw on the independent analysis earlier, where it's filtering down to 20 micron. That's when the sand is new. Over time, that will deteriorate as it becomes subject to biofouling. With AFM, you're getting 1 micron. You've got that barrier already against Cryptosporidia.
Okay. I think I'm achieving 40, so I'm probably
Perfect.
So it should be all right.
Perfect, yeah.
I've got a question about no-frost. Do you want me to leave that till afterwards or something? 'Cause it
Yeah,
might-
come and see me
Yeah,
afterwards, and as I say, anybody's welcome to join us on our pool pro day on the 7th of May up in Edinburgh. Just come and see me for more details. So there's no more questions, and thank you very much for listening to me drone on.